This video covers everything we did in class today on Monday, January 31st. To follow along, you need to open the ClassKick link right above this video in the asynchronous work folder. Pause here, open up ClassKick, and return when you're ready for the do now. You should have ClassKick open and your slides should match mine. I want you to pause the video and complete the do now, questions 1, 2, 3, and 4. These directions are going up right here on the slide. When you're finished with the do now, you can check your work in today's notes, which are also posted in today's folder, Monday, January 31st. At this point, you should have completed the do now on slide 1. If you still haven't, please pause the video. And again, you can check your work in today's notes, which are posted in the main folder for today. On slide 2, you'll see the learning target and agenda. Today's learning target is I can solve problems that involve multiplying and dividing rational numbers. We focused on activities 1 and 2 in lesson 12, took an exit ticket, and then discussed the homework for quarter 3. Meet me on slide 3. 12.1 grapes per minute. 1. If you eat 5 grapes per minute for 8 minutes, how many grapes will you eat? Question 2. If you hear 9 new songs per day for 3 days, how many songs will you hear? And question 3. If you run 15 laps per practice, how many practices will it take you to run 30 laps? Your directions are to pause this video and complete slide 3, questions 1, 2, and 3. That's activity 12.1. At this point, you should have tried questions 1, 2, and 3 on your own. The key discussion that we had in class is that these questions take us back to our notes from lesson 7 and 8 when we discussed distance equals rate times time. For example, in question 1, if you eat 5 grapes per minute for 8 minutes, you can determine the total number of grapes that are eaten by calculating the rate times the time, which will equal the total. Of course, in this case, the total isn't distance, but you're multiplying rate times time to determine the total number of grapes that are eaten, which is the same concept as that familiar formula. The same would be true in question 2. 9 songs per day for 3 days. When you multiply the rate by the time, you can determine the total. That's because if we know we're finding 9 songs per day for 3 days, we have 3 groups of 9. Another key concept from 12.1 is this word per. We've discussed how the word per without a number, for example, per minute or per day, can be interpreted as per 1. So when you see the phrase 5 grapes per minute, you're seeing 5 grapes for every 1 minute, or 9 songs per day is 9 songs for every 3 days. A common mistake that students made on question 3 was repeating the process for questions 1 and 2, where they multiplied the 2 numbers that were given in the problem. That's why we need to underline key information. Because if you run 15 laps per practice, and you're given the information of how many laps you run in total, 30 laps, you won't be multiplying laps per practice times 30. That would give you a very large number, and probably more practices than you would have in any reasonable amount of time. Instead, you want to think about it as rates times time equals total. In this case, we know that the rate is 15 laps per minute, and we don't know the time. We're multiplying it times some amount of time. That is equal to 30 laps. And so you could either use your prior knowledge to determine the missing number in this multiplication sentence, or you could use inverse operations, which is what we're moving towards. 30 divided by 15 is equal to 2, and that's the amount of time, 2 practices. If you'd like to check your work specifically for questions 2 and 1, you can again open today's notes in the main folder. Slide 4, 12.2, water level in the aquarium. A large aquarium should contain 10,000 liters of water when it's filled correctly. It will overflow if it gets up to 12,000 liters. The fish will get sick if it gets down to 4,000 liters. The aquarium has an automatic system to keep the correct water level. If the water level is too low, a faucet fills it. If the water level is too high, a drain opens. One day, the system stops working correctly. The faucet starts to fill the aquarium at a rate of 30 liters per minute, and the drain opens at the same time, draining the water at a rate of 20 liters per minute. I want you to pause this video, and I want you to underline key information in question 1. Okay, at this point, you should have underlined key information in question 1. If you haven't underlined and circled the question, you should pause the video again. A says, is the water level rising or falling? We know that the faucet is filling the aquarium at a rate of 30 liters per minute. And at the same exact time, water is being drained at a rate of 20 liters per minute. So if you can imagine an aquarium tank, which I find it can sometimes be helpful to draw, we know that water is going into the tank at a rate of 30 liters per minute. I'm going to write LPM for liters per minute, 30 liters per minute. And we know that water is coming out of the tank at a rate of 20 liters per minute. So the question is, if we know the speed at which water is entering the tank, and we know the speed at which water is exiting the tank, is the total water level getting higher or lower? Go ahead and answer that question under A. In part A, you should have stated that the water level is rising because water is being added at a faster rate than water is being drained. And we can tell that in every minute, 30 liters of water are added and 20 liters of water are drained, which means in total, we are adding 10 liters per minute because that's the difference between the amount of water that's being added and the amount of water that's being drained. And so in question 2, we need to figure out how long it will take until the tank starts overflowing. We know that the tank is going to overflow because the level is rising, not falling. We also know that the large aquarium starts off with 10,000 liters of water and overflows when it gets up to 12,000 liters. So we start at 10,000 and we know it overflows at 12,000. We know that the rate is 10 liters per minute because, again, that's the difference between how quickly it's being filled and how quickly it's exiting the water tank. So your job is to figure out how many minutes is it going to take to get the tank from 10,000 to 12,000 if it's being filled at 10 liters per minute. I want you to pause this video and try question 1B. So in this situation, we know that we can multiply distance equals rate times time. We know the distance. The tank is being filled 2,000 meters from 10,000 to 12,000. The rate is 10 liters per minute. And what we don't know is the time. Since time is our mystery number, we can simply divide 20,000 by 10 for 200 minutes until the tank overflows. We use the inverse operation of multiplication to find time, which is the missing value. Question 2 is very similar. I'm going to leave you to try question 2 on your own. You can pause this video here, or you can listen to the rest of the directions. On slide 6, you'll see a summary of today's lesson, and that's where you can review all of the information from this video and information that you might need to complete today's homework. On slide 7, you'll see today's exit ticket, which is due by the end of the day today. Tonight's homework is posted in Delta Math, and it's due on Friday. In class, we discussed that in quarter 3, we'll be moving towards one longer homework assignment a week, and we can talk about that when you return to school. If you have any questions about the directions in this video, please send me an email.